Hello guys, another problem with the springs. It says the spring, the only one, has a stiffness of 800 Newton per meter and an unstretched length of 200 millimeters. Determine the force in the cables when the spring is held in that position. Well, this is force, right? And this is force BD. And we can calculate alpha and we can calculate beta, so we are okay with that part. Now we need a force here acting in that way. This is the way these problems work all the time. So we can have two unknowns and solve for them using a system of equations, most probably. But we need this force. Well, but we know the unstretched length and we know the stretch length. The problem is giving us to us. So then we can actually calculate how come this this spring went from 200 to 500 due to what force. For that, we need the stretching of the spring. And the stretching of the spring will be the final position or stretch minus the original or unstretched. So the stretching of the spring will be 500 millimeters minus 200 millimeters. Will be 300 millimeters or 0.3 meters. And we know that the force is the constant of the spring times the stretching. Well, for that spring we have 800 Newton meter and the stretching 0.3 meters. Cancel. The force will be this times this is 240 Newton. Once we have that force over there, the problem just becomes a simple regular problem as any other that you have done and you have watched me doing. Summation of forces in X equals 0. We're going to need alpha, we're going to need beta. So we can do sine, cosine, we can use 3, 4, 5 if you want to, because obviously this is 45 degrees. I don't even have to calculate it because it's inverse tangent of 400 divided by 400. And this will be 3, 4, 5. But we can calculate beta as inverse tangent of this is beta 3 over 4 or 300 over 400, which is the same. Inverse tangent, bullet. That's 36.87 degrees. And that's it. And alpha equals 45 degrees. Same thing, inverse tangent of 4 divided by 4. So let's do X. This will be FBC cosine 45. This will be FBD cosine beta, assuming XY. And this will be negative 240 because it goes to the left. So, my dear friends, that will be FBC cosine 45 plus FBD cosine beta 36.87 minus 240, but I'm going to pass the minus 240 to the other side. Remember, this will be here, 240, but I'm going to pass it to the other side. Just to arrange the equation, 240. And if we do summation of forces in Y equals 0, then we have this component, FBC sine alpha, this component, FBD sine beta, but this is negative because it points down, and this is positive because it points up. So FBC sine 45 degrees minus PV sine of beta equals 0 because there's nothing else acting in the y direction. And we solve again this system of equations with our system solver. First term, cosine 45 plus cosine 36.87 equals 240. Sine 45 minus sine 36.87 equals 0. Solve. If BC, which is x, 145.43 Newton. If BD, which is y, 171.39 Newton. Booyah! No? Done. Easy peasy, lemon squeezy. I mean, I want you to be as comfortable as I am by doing this type of problems because they are easy. Keep watching, guys. See you next video.